Hello students, today we study electric field intensity at any point, that is at any general point due to electric dipole. Consider a short electric dipole AB which consists of equal and opposite charges minus q plus q separated by the small distance to A. We know the direction of the dipole moment is from negative charge to positive charge, so it will be in this direction. To find the electric field intensity at any general point due to the short electric dipole, consider a point P at r distance from the center of the dipole O. And this line OP is making angle theta with the dipole moment direction P. Now what are the rectangular components of the dipole moment? That is P cos theta axial component, P sin theta perpendicular component. P cos theta is along the OP line and P sin theta is perpendicular to OP. Now what is the electric field intensity at the P point with respect to P cos theta with respect to P sin theta? The point P lies along the axial line with respect to P cos theta, and the electric field intensity along the axial line at P point is 2 kp divided by r cube. So we write it as 2 kp cos theta divided by r cube. It will be in this direction. It is denoted as E1. Now what is the electric field intensity at the point P with respect to P sin theta? With respect to P sin theta, the point P is along the equatorial line, and along the equatorial line the electric field intensity is opposite to the direction of the dipole moment, so it will be in this direction and it is denoted as E2. And we know the electric field intensity along the equatorial line is Kp divided by r cube, so it becomes Kp sin theta divided by r cube. So the electric field intensity at the P point due to P cos theta is in this direction. With respect to P sin theta is in this direction. So the resultant electric field will be in this direction. And the resultant electric field we know root of E1 square plus E2 square. E1 square is 2 Kp cos theta divided by r cube the whole square. E2 square is Kp sin theta divided by r cube the whole square. Kp divided by r cube whole square is common term, so we can take out of the root. It becomes Kp divided by r cube root of cos square theta plus sin square theta. We write sin square theta as 1 minus cos square theta. It becomes Kp divided by r cube root of 1 plus 3 cos square theta. This is the electric field intensity at any general point due to the short electric dipole. And this resultant electric field is making angle alpha. How do we find that angle alpha? We find the angle of the resultant electric field as tan alpha. Tan alpha is nothing but opposite side by adjacent side. Opposite side is the electric field along the equatorial line divided by the electric field along the axial line. We know along the equatorial line it is Kp sin theta divided by r cube. Along the axial line is 2 Kp cos theta divided by r cube. Kp r cube get cancelled, so it becomes sin theta divided by 2 cos theta. It is half tan theta. So the angle of the net electric field is tan alpha half tan theta. We write alpha equal to tan inverse of half tan theta. Now what is the angle of the resultant electric field with respect to the original dipole moment? It is alpha plus theta. So this is what the uh, angle of the resultant electric field with respect to the original dipole moment, that is theta plus tan inverse of 1 by 2 tan theta. So this is what the electric field intensity at any general point. From this, how do we calculate the electric field intensity along the axial line at the equatorial line? Along the axial line, we know the angle between the electric field intensity and the dipole moment is 0 degree. So when we substitute 0 degree in this formula, we get the electric field intensity along the axial line, that is 2p divided by 4 pi epsilon naught r cube. And the angle between the electric field intensity and the dipole moment becomes, that is alpha equal to 0 degree. And when we substitute theta is equal to 90 degree, that is if we want to find the electric field intensity at equatorial line, substitute theta is equal to 90 degree in this formula, we get P divided by 4 pi epsilon naught r cube, and the resultant electric field is at 90 degree with the dipole moment direction.